let's go ahead and get started with the webinar. We're going to talk first a little bit about considerations you want to take when choosing a material. I'll tell you guys a little bit about our Saratech approach to 3D printing. Then we'll look at some materials that are using fused filament fabrication, FFF, or sometimes known as FDM technologies. We'll see a couple materials that are related to powder bed technologies, along with some interesting applications for both. And we'll close out this session with some questions and answers. So let's jump right into it. So when you are choosing a 3D printing material, there's several things you need to consider. And as you guys might already know, there are tens and probably hundreds of different 3D printing materials that you can choose from. So it can be a little bit daunting to try and figure out what it is you need for your application. So of course, one of the main things you might look at is strength. How strong is the material you're going to be printing with? But that's not the only consideration, of course. You need to also consider the environment that part's being used in. If it's a high temperature environment, you may need to select a different material. If there's going to be caustic chemicals around, you may need a different material as well. Another important consideration, of course, is cost. We often turn to additive manufacturing or 3D printing for the three pillars: better, faster, and cheaper. And if your process ends up being very expensive due to the material you choose, then overall it's not a great solution. So really it is finding a balance between all of these different material properties, costs, and different aspects of this material that's going to get you the best results. So a little bit about Saratech. Saratech is a 3D printing company, Saratech is an engineering company, as Nika mentioned, but we also offer 3D printing services and hardware. Now, we do work with 3 different OEMs machines, but today's webinar is about materials in general, and there are so many different materials and different machines that can print the materials we're going to talk about. But these are just the machines that Saratech uses. So I'm going to frame it in the context of this equipment, but a lot of this will apply to many other devices as well. So the first machine you see here is from Markforged. That is going to be our FFF, fused filament fabrication, or FDM technology we'll talk about. And we'll see a couple materials from that. And then the next one is the HP, which is a powder bed system. There are many other powder bed systems out there as well, which these materials are applicable to. And then Big Rep is another FFF solution. It's a large format printer that we can print with, very large parts, and it will run a lot of these similar FFF materials as well. So let's jump right into the FFF. As I said, it stands for fused filament fabrication. The trademark name is FDM, fused deposition modeling. It is a technology that uses typically a spool of a filament of some sort of plastic that is heated up, pushed through a nozzle, and prints out your parts. And if you guys are printing at home, you may know there's a lot of different filaments out there. You have your standard PLA, you have PETG, maybe ABS, and other sorts of materials like that. So let's talk about the most basic one that everybody knows, which is PLA. PLA is a thermoplastic, of course. It is probably the most user-friendly material to print. If you are working on a home, maybe a hobby level printer, PLA usually prints with 0 issues whatsoever. It is also one of the cheapest materials out there. So that's why a lot of people generally go to PLA right off the bat. It is not the best engineering material, of course. It doesn't have really great chemical resistance. It's not good under heat. It's not very strong either. So what it's great for, though, is prototyping. So if you have to do lots of designs, a lot of iterations, and you want a visual prototype, it's really great for that. You can do fit checks. You can do all sorts of design. And some of the larger things, if they're not under very high loads or high heat and temperature, you can use PLA for that too, to save on costs as well. Now, as I said, we'll put this in the context of Markforged a little bit. The Markforged printers that we use can print with a variety of materials, PLA being one of them. And what's really nice about using the Markforged system for that is that you're keeping one single printer to print all these different materials. So you can kind of expect what your results will be The Markforged machines are very accurate and repeatable. They're very robust machines as well. So that's why we like to use them. Now, of course, PLA, like I said, is not going to be our highest performance material. So let's talk about another material that is a little bit better for that. The material is going to be nylon, and Markforged does have their own version of it. They call it Onyx. And what that is a base of just a nylon 6 with chopped carbon fiber or powdered carbon fiber that's added in there for stiffness. Nylon is a really versatile material. It is a bit harder to print with. So if you're printing at home, you know you need very high bed temperatures, nozzle temperatures. You may need to have a draft shield to keep the environment around it, the air very still. So it's not an easy material to print with unless you're using a dedicated machine. Like the Markforged is dedicated and specializes in this nylon filament. The carbon fiber added to this nylon does have the added benefit of also giving a really great surface finish. It's almost like a matte surface finish, and it really hides those layer lines that you see on a lot of FDM or FFF parts. I won't go too in depth with this table here. This is just some of the properties of just regular nylon on the very right-hand column, just plain nylon, and then on the second. The first column there that says Onyx, you can kind of compare the properties between just a plain nylon 6 with the Onyx, which is nylon with chopped carbon fiber added to it. So you can see the change in tensile modulus and stress at yield as well. So a little bit of differences there. What is it good for? Well, this material, we use it in a wide variety of applications. Functional prototypes, so whereas PLA, you'd be using your more visual prototypes, this Onyx material is great for end use, one-offs, or functional prototypes that you need to actually test loads and use it under a more rigorous environment. Because these machines are so repeatable, they're great for making jigs, fixtures, toolings, any sort of manufacturing aid that you might use or CNC. And a bit more on that in just a second. And to further add more materials into the mix, the Onyx family does come in a couple varieties as well. There's a flame retardant version and an electrostatic dissipative version. Won't go into that too much right now. But what's really neat is that they are compatible with continuous fiber reinforcement. Now, there are many materials out there, even for your home printer, that say they are a carbon fiber material, but that just means that it has the powdered carbon fiber that Onyx has. What we're referring to here is continuous fiber that is actually laid out into the part to drastically improve the strength of the material. So you can see from this stress strain curve here, the very bottom line is that Onyx material just on its own. So that would be kind of similar to what the stress strain curve of just a plain nylon would be. But you can see that by adding these continuous fibers to it, it drastically improves the strength of the material. And what's really incredible, on the far left of the graph, you can see that this nylon reinforced with carbon fiber is as strong as 6061 aluminum up until its yielding point. So going back to what I was saying about CNCing, it's a really great way to be able to replace machined aluminum parts with 3D printed plastic parts. There's so many benefits there, and we're going to see a case study in just a moment here. But when you're CNCing or traditionally manufacturing your aluminum parts, you have the material cost, of course, but then you have what's even higher is the programming time and the machinist time, and the machine time itself to run those parts adds up very quickly. So parts can become very expensive, especially if you're not doing it in-house, you're outsourcing it as well. So we'll see a really great example of where we were able to successfully replace a machined aluminum part with one of these carbon fiber nylon parts. This table here shows some of the different continuous fibers that are available to route within the part. Carbon fiber is going to have your highest strength to weight ratio. It's the stiffest material. It is also the most costly. So when we're balancing cost against performance, you have to take that in mind, that carbon fiber is a very costly material. let's say, for example, maybe weight is not critical to you. Then fiberglass is a really great option because you get a lot of the same strength from carbon fiber. It is much heavier, however, but it's a much cheaper material. So you kind of can weigh the benefits and say, well, you know, I just need this to be strong. I don't really necessarily need it to be lightweight. Maybe I'm not building a drone or something that's going up in the air. Then you can turn to fiberglass. There's also a high strength, high temperature variant of fiberglass, as well as Kevlar, which is great. It's impact resistant. You can do a lot of really cool things. It bends and deforms rather than fracturing like the other materials will do. We did a couple months back, we did a full webinar on using the Markforged printer with these different fibers. So if this is something of interest to you, please go back and check that out and learn a little bit more about that. So jumping into the application here, one of our customers, Gamma Aerospace, they came to us and they were making these forming blocks out of aluminum. And the forming blocks were only for low run parts. So they were only doing maybe a few hundred units a time. So the investment in the forming block itself was quite costly compared to the part cost. So they said, well, you know, we're paying a CNC programmer right now about 3 hours of programming time, plus about 2 hours of machine time to cut this part. It was costing them upwards of $500. They were interested in 3D printing, and before they contacted us, they even tried printing this out of another material you might have heard of called PETG, as well as ABS, and they printed this part completely solid. So there was no infill or anything like that, and still it was not able to hold up to the forces that they were stamping these parts at, which was about 2,500 PSI, so very high loads. So they came to us and said, hey, you know, we realize you guys have this Markforged technology that can print high strength composites, and we took a look at the part, we did a little bit of analysis on it, added the carbon fiber reinforcement, and the result was that it held up great. They got over 200 stamps out of this part, held up under the loads and pressures, and it saved them money. Not only did it save them money on the part itself, it freed up their machinists to work on other money-making activities for the company. So this was a really great success story that we love to see and help other customers repeat. So that's the high-strength Onyx material. Now let's jump into something a little bit softer. So let's say you need something that's flexible. You may have heard of TPU material before. That's another printable material you may be able to print at home. But as you might know or have some experience with, it's a very difficult material to get right. It's very sticky. It's some describe it as boogery. So it's a really hard material to print with. But if you can get it right, the result is that it is flexible, it's impact absorbent, and you can make a lot of really interesting things that you couldn't do with a hard plastic, such as gaskets, seals. Because it's soft, you can make non-marring work holding pieces. So let's say you need to hold a polished part or a painted part that you don't want to scratch. TPU is a great option for that as well. You can do things like drive belts and protective coverings, phone cases, all of that. Now, Markforged also prints this material, of course, and it is they've tuned it in beautifully, so it prints great every time. You don't have to worry about any adhesion issues or anything like that. It is a little bit of a slower material to print as a result, so you're going to be doing low volume quantities of these TPU printed parts. What also is very interesting about the TPU is, although it is a soft material, its overall stiffness is a function of the part geometry as well. So, you know, let's say you need something that's a little bit stiff, right? You can increase that infill density of the part, and it will increase your flexural modulus. And the opposite is true. If you give it a very sparse infill, it'll get more flexible as well. So with clever design, you can get more a wider range of properties from this one material, which is really neat. So TPU is definitely one that a lot of people don't think about because, you know, you think of hard plastics, but you can make really interesting stuff with these flexibles too. So keep that in mind. So let's change gears a little bit now and talk about some of the powder bed technologies. There's a lot of different powder bed SLS systems, multi-jet fusion systems, and binder jetting. So the one that we use here at Saratech is called multi-jet fusion, and it's a technology developed by HP. And it is similar in properties to like an SLS would be, much stronger than a binder jetting process would be. And the first material we'll talk about that uses this technology is going to be the PA12, Nylon 12. So we were talking about this Onyx material, which is also nylon. This is also a nylon as well, just printing on a different platform. Does not have the carbon fiber, but we'll see where there's other benefits to this as well. So just real quickly comparing it to PLA, we can pull out data sheets too, but really it's night and day between PLA and nylon. It's a much more durable material, definitely a lot stiffer, tougher, has better chemical resistance as well. So much more engineering grade material. So what can you do with Nylon 12? Well, especially on a powder bed technology, printing it on powder bed enables some really cool design freedoms that you can't do with FFF or FDM technology. If you guys have experience at home with it, you know, FDM, they do require supporting structures if you exceed a certain overhang angle. So that ends up limiting your geometry and your design freedom. With these powder bed systems, the powder that goes into making the part, it's everywhere. So it's actually supporting the part as it prints. The result is you can get some really interesting designs out of it. So if you see the photo on the left-hand side here, this is a leading edge of a wing that we modeled, and we filled it with this very lightweight lattice structure that goes all the way through. Now, you can imagine this would be pretty much impossible to print on an FDM or a FFF machine, because how would you get all that support material out of there? It wouldn't be possible. But with a powder bed solution, you can come up with crazy ideas like this, and as long as you're able to get air in there to depowder it, you can your imagination is really the limit for these. Another benefit of that powder bed process and being supported by the powder is that you can also do print in place assemblies. So the part on the right here is one that we designed for a customer, and it's a collar that goes around a tool and tightens on the tool. And we printed the bottom part as a single piece. So there's no additional assembly required, no additional fasteners or hardware to make that hinge joint. It all comes out as one piece. Another really great application of this Nylon 12 is that it is also a very commonly used injection molding material. So a lot of mold houses will use PA12 for their final products. And if you are planning or making a product that you intend to mass produce later on, it's always really great to be able to test out your prototypes in the same material that the final product will be in. So that's really one of the great benefits of using this PA12, because you get a lot of that design freedom, but it's very similar to what your end product might be. So one really cool case study comes from KOCH Pac-Systeme, and they produce these blister packaging and different types of packaging equipment. So the machines that make the packaging equipment, and they're custom making these machines to customer specs. They may have different size equipment that they're putting into blister packs, so they need to make all different sorts of custom parts. So, you know, traditionally they might be injection molding these, and maybe probably a lot of CNC machining as well, which is very expensive. Typically, injection molding, you don't do it in-house. You send it out to a mold house to get done. There's very high upfront tooling costs to make those molds. And then, of course, you are limited by the geometries, the design freedom as well. So KOCH, they adopted the HP technology using the PA12 material, and they were able to not only increase their part complexity, but they were able to prototype much faster. And once they arrived on a design that they liked, then you know, they didn't have to send out to get it injection molded. They can print it in-house, shortening their lead times. Just an overall more cost-effective solution. So you can really see how this is a great solution for somebody who needs to make a lot of rapid iteration parts and then use those as the end-use parts as well. So let's talk about another powder bed printing material, and that is going to be polypropylene. Polypropylene, this is another printable material that can be used on the HP machine. And it has excellent chemical resistance. So this is what you're going to use if you need to maybe have a pressure vessel or store some sort of caustic solution or liquid. It has very low moisture absorption. So you may know that nylon does tend to absorb a little bit of moisture. It can swell a little bit when it does. This is not the case with polypropylene. It is, of course, weldable. So, you know, this part that you're seeing here, and we'll talk about this part in detail in just a moment here, it was actually printed in 2 separate pieces, and they welded those 2 halves together using a hot plate welding method. So, you know, you can do a lot of great post-processing after the fact. And polypropylene is another one of those materials that's very commonly injection molded. So if you are making the part and you intend to get it injection molded in polypropylene later on, it's always good to test your prototypes first in the same material. Just a very quick comparison, I won't go into too much depth, but you can see there's quite a difference in strength between the two. Polypropylene is going to be a softer, less durable material, but it is definitely more chemically resistant. It is also, polypropylene is also much lighter. As you can see from the density is less than that of nylon 12. So again, it's all about balancing your needs, your characteristics for that particular application. So let's talk about Exitol. They are making these parts, basically fluid reservoirs for automotive applications, and they were injection molding these. Of course, 7 weeks to get their parts because you have to send out, get the tooling made, get the parts made, ship them back to you, and then you have, that's going to delay your testing process, your validation process. So they adopted the HP technology as well. And they were able to reduce their lead time down from 7 weeks to just 6 days, which is really incredible savings. And of course, it's polypropylene, the same material they were using before. So the result here was just much shorter development and cycle time. So, you know, saving a lot of time on getting their product to market faster. So we talked about several materials. There are plenty more materials that we can talk about. I can talk about 3D printing all day long. If you want to know more, please contact me and we'll talk about it. But some of the key takeaways here, and really you can apply these to other materials that you're interested in as well, is all about balance. So you need to look at what your application is, see what type of loads and strength that part needs to be. But don't just stop there. Then look at maybe its operating environments. If you need something that's going to be a little bit higher temperature, you may want to consider that as well. Maybe that higher temp material is not as strong, so you need to compensate in your design, make it a little beefier. And then of course cost, always thinking about cost. If you're trying to make things better, faster, cheaper, it has to be cheaper, of course. So all these materials we talked about today can be printed on other technologies, but Markforged and HP were the ones we talked about. So I hope this was very informative for you guys. And right now, we'll go ahead and open up to questions if there are any.
So we do have a few questions. So are there any comments on carbon fiber infused PETG?
Great question. So I have not seen any carbon fiber PETG recently, but the thing to consider with that is that it will increase your stiffness, but it may not, that may not always be what you need, right? Because PETG is a more ductile material, so it will yield a little bit better than a harder material. So by adding that carbon fiber, you make it stiffer and more likely to fracture. So yeah, there probably are companies out there that are making a material like that. But again, just look at their data sheets. They'll have all that information listed there. Great question.
Is there a difference in strengths between an FFF and powder bed printed parts with the same nylon material?
Ooh, that's a good question. Yeah, there are definitely differences. So yeah, we talked about Markforged nylon, we talked about HP nylon. Both of them are nylon materials, but what will make a big difference is actually that printing process. So if you're familiar with the FFF or FDM process, it's going layer by layer, and molten plastic is being deposited onto the layer before it. What happens in that case is that the adhesion between layers tends to be a little bit weaker than the actual material strength itself. So if you're building up a part, in the Z direction, you're building this tall part, you're going to have a weakness along that Z direction. So that's always one thing you want to consider when printing. Now with the nylon system, the SLS and the HP multi-jet fusion systems, they are completely melting the layer before it to the layer above it. So you get much better isotropy, and the parts are nearly the same strength in all directions. So that's a really other key point to know about using a powder bed system, is that if you're making something, a great example I always see is like snap-on parts that have little clips and stuff. The part itself is always really strong, but that little clip that usually sticks up is very weak because of the Z, the layer adhesion. So you don't have that issue with the powder bed system. So keep that in mind. So great, really good question.
Thank you. And we have one more question. I need materials that is flame retardant. Do you know of any materials for this application?
Yeah, so I briefly went over it. I didn't go into too much detail because we had another webinar specifically on the Markforged nylons, but the Onyx family does come in a few varieties, one of which is a flame retardant version that is UL V0 rated. So that is excellent if you need a flame retardant material that is available. Thanks for that question.
Great. And it looks like those are all the questions we have today. And I just wanted to thank everybody for joining us. If you want to follow us on our social media, please go ahead and do that. As well as if you have any other questions or comments, please contact us at info@saratech.com. And thank you so much, Andrew, for presenting.
Thank you for having me. Hope everyone has a wonderful rest of your day.
Thank you, everybody. Have a great day.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.